I'm a software engineer from Go1. Go1 is an online training platform. So we work a lot with user environment, and yeah, we have a lot of problem with that too. Yeah. So about event-driven, it's not for game development. It's just about a basic HTTP service. So because we have mostly PHP MySQL developer over here, so it's just a standard HTTP service. Yeah, so you can have a big picture of what I'm going to talk today. Yeah, it's not about system communication like event bus or something like that. It's just about how we design a new service, a new microservice system based on events. Okay, let me go back to the system we are building. Yeah, so this is very tradition pattern we are using these days. Client send a request to a microservice, and then the service read the database or write data into the database. If something happens, the message will be sent to the queue, and for integration, the other services will listen to the queue. So, are you using this pattern for your services? Yeah, are you? Okay, I found some problem with this one. I will go one by one. Yeah, the first problem is the database transaction isn't safe. For example, if I do something with write something to database, I start the transaction, write something to database, and after doing something, I publish the message to the RapidMQ. Yeah, and then I go back to commit my transaction. At that time, the transaction failed to commit for some reason. I don't understand. Yeah, and so that the other services receive the message, but actually that's not completely processed yet. So it's a huge problem for us, because 99% is 99.99% is working fine, but some edge case we have problem with it. Yeah, that's problem we have with the database. And the other problem when we face is sometimes the queue is not receiving the message. Yeah, everything is done very well inside the microservice, but when it's published the message, the RapidMQ doesn't accept it, reject it. And yeah, we also have that problem. For example, if for example, if you wish to buy something, pay something, and the delivery service can't receive message, so that would be a big problem for the system. So we also face this problem a lot. Yeah, it's a very big problem. Yeah, the other problem with the queue is that actually our business logic should not depend on the queue. Yeah, adding the dependency into the queues just slow down the business logic inside my service. For performance testing, I hit 1,000 requests into my service. The PHP working well, engine is working well, MySQL working well, but actually because it's PHP, every request is make one connection into the queue, so we unable to serve 1,000 requests per second because of that dependency. So that's also the big problem. We launched a lot of PHP instances. We scale up everything, but we can't serve that amount of requests because of queue dependency. So it's another problem with the queue as well. Yeah, with that stress test, you can see that even if you increase the server resource for the queue, add more node into the cluster, yeah, some is working very well, but the other services cannot process that number of messages fastly. So the more and more messages will be stuck into the queue, and if you have some millions messages in RapidMQ, it's really very easy to be the server is hang. And yeah, because our service depend on RapidMQ and it's stuck here, the system die because one problem. It's just 2 services, but actually in production we have hundreds of services depend on the queue, and a system with this pattern. Yeah, we scale the queue. We add a lot of nodes into the queue, just serve. That's a problem. Yeah. So yeah, it's just explanation for. Sorry. Yeah. Okay. Just a joke. Yeah. Yeah. Go back to the diagram here. So we make a lot of network I/O. So with the pattern, the system is very slow, because to handle each message in the queue, the service will serve 1 HTTP request and return HTTP response. So it's very slow using this pattern. Yeah, the I/O is a big problem. So we need a new pattern. So we reduce the network request, as well as resolve the problem I explained earlier. So what this is also the very big problem we having, like we don't understand why the enrollment record changed from in progress to completed, or is when it changed to completed into in progress or not started. Everything changed in our system. We don't understand, because requests come and respond out. We don't store anything. So when the customer go to ask our support team why it's happening like that, and we don't have the answers, because or it's really hard to give the answer for some bugs, some problem happening in our system, because we don't store anything. Yeah. So yeah, a lot of problem with very simple architecture. So that's why we are finding new one, and this is it's event driven. Yeah. So do you see any different? We will remove the we remove the RapidMQ. So when the request comes into the service, it just write data into the stream and then return the response. We don't depend on RapidMQ over here. Yeah, that's simple. Yeah, I didn't show any code over here, because when we understand the diagram, when we understand the architecture, we will implement it. Very, very easy. Yeah, not a problem with the coding over here, because it's very, very simple. Yeah, no more. Yeah, let me go back to the problem we have. No more bad transition. Okay, sorry. Yeah, no more depend on the queue. We have self transaction. We have list IO operation in the system. The system become much more reliable. Yeah. So let me explain how this is how the transaction is set. Before, we depend on 2 servers to complete a single transaction. Now with a single server, we just depend on the stream. If we can't commit the event into the stream, we can't complete the transaction. In that case, we just abort the request or raise error. So say that the transaction is not complete, retry it later or something else. Yeah, for sorry, I forgot the thing. Extra dependency. So yeah, because one case problem. Yeah, because we are using event stream, everything will be in the stream. We use same storage for service consuming. The service, instead of listening to the queue, we read the stream for the event to process. Yeah, for single process, it can start from here, and as long as can process, it can process as much as it can. Yeah, for example, if the stream we have 1 million, yeah, with a single process, we can consume 1 million messages at one time. So the we reduce a lot of network I/O over here. So the system just become very, very fast with this approach. Yeah, and with this problem, because we store everything, because user commit event into the system, we capture it, we put in the stream. We don't lose user request. User request is now just the event, and we store everything into the event stream, so that when we have some problem with certain environment, we have some problem with certain object, we just go back into the stream, we filter what's happening with that, and easier to debugging, easier to explain everything. Yeah, to implement it, to implement it, we treat everything like event. Like in our system, we create enrollment, we manage enrollment. To start to rework on the enrollment system, we just define how the enrollment is created. Yeah, we define enrollment create event. We create enrollment started update event. We create enrollment delete event. So we can think everything in our system is just event. Yeah, when we have a enrollment over here, it's just a state of the enrollment. Enrollment is just a state of events around that. So quite easy. Yeah, for each event, we define a handler for it. like environment create. Yeah, the handler is just validate it and write the state of it in MySQL database, and then we say that hey committer, the event is successfully handled, and then the committer will write the event into the stream, and committer just return that, hey, it's okay, use it. Yeah, the RESTful is just common transport pattern, so we can using any communication pattern for it. Yeah, for example, we just use the RESTful pause into the server, and the body is the list of event to be committed. Yeah, and yeah, the question is how we store the event, because I only understand MySQL very well, so I store everything in MySQL. Yeah, I define enrollment stream. Up there, I store enrollment event ID, event type, event payload, who created, which organization is happening. So everything I store in MySQL. Yeah, but for a long time you can't store everything in MySQL. So in that case, we just store the stream of event in 2 months, and after that we will archive it. We archive it into S3. Yeah. So the table is not always is not big as you think. Yeah, we can partition it. You can archive the data. So for big data, for big amounts of events, you can archive it. Yeah, instead of 2 months, you can keep it in 2 weeks or 2 days, for example, for some. Yeah, this we don't have any problem with event streaming storage. And you may have a question that how the services can, yeah, how the services know that what's happening in our service. With the RapidMQ pattern, everything happen in a system, it publishes a message, so the other service will receive a notification. But if we're using the MySQL, we don't have the tool for that. So the question is, yeah, how we resolve that problem? In the service, in the service, we have a sidecar over here. Yeah, sidecar we use PanToss. So every time some event happening in the service, we will ping a message into the sidecar. So every 1 second, for example, every 1 second, it will aggregate all services, and it will ping RapidMQ over here. It would just send one message. If we have 1,000 messages per second, we just send one message into RapidMQ. In this case, RapidMQ will ping the other services. Yeah, the other services just understand that something happened in our domain. Yeah, when the external service know that something happened, it will read the stream. Yeah, like we have 1 million in events in the stream, and from starting, it will start at the offset 0, and yeah, like say it process 100 messages, and it stop. And when it stop, it store their offsets. Yeah, they already process 100 messages, and the next time they process they just start at the 100 offsets, and then just they go as long as they want. The memory is very good. The yeah, everything we process as much as possible. Yeah, that pattern for the sidecar we use Bentos. You can go to GitHub, search for that software. It's very simple. I deployed. I use Bentos, just small configuration. It can start event aggregator for me. Quite easy. Bentos is also a very good software for, yeah, you can for Pi operation. Yeah, it's written by Go. Just a small, very small binary to run together with our main service, run as sidecar. Yeah, it's very similar to Elasticsearch log start. Yeah, if you run log start, it's a Ruby application. It's quite big, but this is Go implementation. It's just a very small footprint. Yeah. So I explain the implementation. Yeah, it's purely in HTTP, PHP, and MySQL. Yeah, a little bit of Go application over here, a little bit of RapidMQ. Yeah, this our implementation, and I very amazing that it's much simpler than I think when we trying new architecture for the system. Yeah, it's my thinking, but actually you may have better idea for the problem. So do you have any to share with topic?
So what are some of the, like, if you're comfortable to share the performance improvements in terms of figures? If you're comfortable to share, otherwise.
Yeah, for sure. Yeah. After moving to the event driven, we can serve the 1,000 requests per second is quite well, and in production, the system is much faster than before. Yeah, because we are just online learning platform provider. We don't need something huge performance like Netflix or other company. 1,000 per second is quite enough for us.
How long would it take to migrate your application from using like a normal tech stack into like using an event string? How difficult is that process?
Yeah. Yeah, the process is quite simple also. Because it's RESTful, you can keep the old interface for it. Like enrollment, I keep the old interface. The legacy system work very well. Internally, I convert the request into the events, so I store it. And yeah, it's like no problem with it. So with event, you can provide new protocol for it, like GraphQL. Just write a converter between, convert the transporter, convert the input to our core event and handle it.
Awesome. Thanks, Andy. Now, pizza's ready. So we had outside. Okay, spaces.